we have a solution where we have the alkyl halide initiator with the monomer, in this case methyl methacrylate, MMA. And then over here, if you can see it, is a nice green solution, which has the copper bromide mixed in with the ligand and the solvent, which is phenyl ether. So it's a nice bright green color. So the first thing that we're going to do is we're going to just transfer this into the solution, which is at room temperature right now. This is all under nitrogen. So this is an example of a controlled living radical polymerization. So right now, we're going to inject the copper bromide ligand solution, which is PNDETA, which is solubilized with phenyl ether. So you see the nice green color. Okay, that's through your copper. Now I'm going to inject this into the monomer initiator solution inside the reactor. Okay, and now we can commence heating. So here is the solution that's being heated up now. So you notice we had that nice bright green. Do you see the color change? It's a little subtle. It's starting to turn a little bit brown. What this is indicating is that your copper bromide, your copper 1, is now starting to get oxidized to copper 2. So that equilibrium that is responsible for the control of the polymerization is starting to take place. All right, so you'll see it progressively getting darker as we increase the temperature. Right now it's at about 55 degrees Celsius, and you'll see it progressively getting darker. So here we are close up at 80 degrees Celsius, which is the set point for the polymerization. Notice this color of the solution has become much more brown compared to that initial green color that we had. So the equilibrium is in full effect, and we should be taking samples shortly. Hopefully we'll get some polymer. Alright, so about 5 minutes has elapsed since the set point was reached. Let's see if we've got a polymer already. So here I have a vial which has some hexane, which is a non-solvent for polymethyl methacrylate. So if we have polymer formed, it should precipitate out, and we'll see a nice little solid goo inside of here. Okay, so let's take a look. We'll take an aliquot from the reactor. Okay. And now I will precipitate it. Let's just mix it up. Here's our Fleury-Huggins equation at work. Let's see if we have a polymer yet. Okay, so you see the solution. It's kind of cloudy. Okay, so it's just we're very early on. Maybe we formed an oligomer at this point. All right, so let's just wait a little bit. We'll take another sample and see if we got a polymer. So it's cloudy, which indicates there's some phase separation, but we're not getting a high polymer form because it would have dropped out very easily. Alright, so now we're about half an hour into the polymerization. Let's see if we've formed a higher polymer. Here's our previous sample that we took. See how it's fluffy? Alright, so we don't got good phase separation. We may have a very short-chained species, an oligomer probably in there. Alright, notice also the greenish color of the catalyst as well. Alright, so here we go into our Brown's reaction solution. Take a sample. Alright. Alright, now this is a little bit different. Let it settle a little bit. So you see it's still a little bit cloudy, but we got a lot more precipitate, so we got a lot more polymer. You can see it's stuck on the sides of the precipitating vessel. Eventually this will settle down Alright, so now we're about 2 hours after we started, and we've now cooled the reactor, shut everything down. You notice the color has changed to that greenish color, indicating the deactivation of the copper. Now let's try and precipitate out our product and see what we've done. So I'm just going to open up through this one side here. Alright, so here's the precipitating solution. And here we go. Oops. Alright, so let's swirl this around a little bit. Let me just get a spatula. Just to ensure that we can recover the polymer. And as you see, we have polymer precipitating at the bottom. Okay, all the copper salts have accumulated within the polymer mass. We precipitated this in hexane. So we're going to recover this. We're going to remove the copper salts, the coloration, because obviously we don't want blue or green polymers in our product. And we'll perform the gel permeation chromatography, and you'll see what the molecular weight distribution looks like for this ATRP of